Hello everyone. So the problem that we're going to be solving today is minimum prefix removal to make array strictly increasing. It was from the weekly contest 486 that was held on 25th of January. So let us read the problem. You are given an integer array nums. You need to remove exactly one prefix, possibly empty, from nums. So what they're saying is that you have an array and you need to remove some prefix. And what is a prefix? A prefix is an array. Prefix of an array is a subarray that starts from the beginning of the array and extends to any one point within it. So what is a prefix? That it starts from the beginning of the array and extends to any one point from the array, right? So basically it can start from one only. It has to start from the first index, and it can be either first two indexes, first three indexes, first four indexes. What it cannot be is this and this, like the first, second and fourth, fifth indexed, something like that, right? So it cannot be that. Prefix has to start and end. So it is a contagious subarray that starts from the first element. So what do we have to do? Return the integer denoting minimum length of the removed prefix such that the remaining array is strictly increasing. Now what is strictly increasing? No number should repeat, and they should be in increasing order, right? So 3 3 4. Okay, let's just start with it. So what example they've given is 1 comma minus 1 comma 2 comma 3 comma 3 comma 4 comma 5, and the other example that they've given, a good one, is 4 comma 3 comma minus 2 comma minus 5. Okay, so let's just see this example first. So what do we need? Firstly, what do we need? Right, first we need a prefix. We need to find a prefix, which is nothing but a contagious subarray which starts from the first index, right? We need to find a prefix. And what do we need to find? What do we need to find else? We need to find the length of the prefix such that the remaining characters, the remaining indices are strictly increasing. So let's say I select this as my prefix, so this should be strictly increasing, right? So the answer for this question should be 1 2 3 4. So the answer for this question should be 4. Why 4? Because see, we start with 1 1. Okay, we check the next element. Is 1 and minus 1 strictly increasing? No, this is smaller, right? So we have to cancel this. So my prefix becomes this. Now I start here. Is this and this strictly increasing? Yes it is. So we can consider this as my prefix, and we are checking all of this, right? So now, is this and this strictly increasing? Yes. Is this and this strictly increasing? Yes. Is this and this strictly increasing? No. Right? Strictly increasing means that it cannot be equal. It has to increase when it goes ahead. Right? It has to increase when it goes ahead. So no. So when I am selecting this as my prefix, I am not getting a strictly increasing order inside the remaining array. So I increase my prefix. I count these two. Again, this strictly increasing. This changes the behavior because it is not strictly increasing when I consider this. So now, okay, this is also not a valid prefix. Now I check for this. I check this as my prefix. So I remove this, I check this. Okay, 3 and 3 not strictly increasing. No. So I take this as my prefix. And I check this. Is this strictly increasing? 3 4 5. Oh yes, this is strictly increasing. So, and my array also ended here. So when I selected this as my prefix, the remaining array became strictly increasing. So this is a valid prefix. So we need to return the length of this prefix, which is 4. Okay, so I think the example is understood, and what do we have to do? Similarly, for this example, we check this is this my prefix? Okay, first we check the entire array, right? Because they have said that possibly empty also, so it can be possibly empty. So I check with the possibly empty. Is this strictly increasing? No, it is not. So I consider this as my prefix. Is this strictly increasing? No. So I consider this as my prefix. Is this strictly increasing? No. So I consider this as my prefix. I consider this as my prefix, and is this strictly increasing? Yes or no? What do you think? So the answer is that this is strictly increasing. Why? Because if there is just a single element inside an array, then that array is increasing. There is nothing ahead of it. So it has to be strictly increasing by condition, because there is no other array array element to be compared from. So it has to be strictly increasing, and hence we consider a singular element as strictly increasing. So this was strictly increasing when this was a prefix. So this is a valid prefix, and we return 3 because this is the length of the prefix. Okay, so I think we understood the examples, we understood what it is we have to do. So now how do we do it? The most brute force approach, which I just explained, is the approach that I just explained is the most brute force approach. You try and check everything, right? You pick this up, you then do this, then check, right? You pick this index and you check if this is strictly increasing. So let's say I write a for loop from index I is equal to 0. No, sorry. From index I is equal to -1, I is less than let's say this is n, array n. I is less than n minus 1. Why are we doing n minus 1? Why are we doing n minus 1? Because I can check till here, na. I can check only till here, right? I can only take from the first to the second last element is prefix, because when the condition of a singular element arises, it has to be strictly increasing. I cannot say that I consider the entire thing as my prefix and my null value that is outside the array is strictly increasing. I cannot say this, right? So I need to stop my prefix here. And why am I starting at -1? Because I need to consider the possibly empty case also. Okay, so I think you all understood. We are starting with -1 because I'm starting my prefix outside of the array, considering the possibly null wala case. And so if I keep at -1, then I need to check if the entire array is strictly increasing. Okay, then I go to 0, then I go to 1, then I go to 2, 0, 1, 2. So this is my this. I cannot consider this entire array as my prefix, because then nothing is remaining, so there is nothing to check for strictly increasing, and hence I stop at n minus 2, that is less than n minus 1. I have to stop at this index, second last index, which is at n minus 2th index. This is my n minus 2th index. Okay, so I think that is abundantly clear. So I plus plus, and okay, this is for my prefix. Okay, so and now what do I do? Now I need to check remaining array array for strictly increasing. Check remaining array for strictly increasing. That is what we are doing inside of this loop. And let's say this is the end of this loop, and here let's say if check of nums comma I is equal to true, if check nums comma I is equal to true, then I just return I, right? So let's say this was my example. My I was here, okay? I considered this as my prefix. This is my prefix 0, 1, 2, 3. Okay, 0, 1, 2, 3. So this was the remaining array which I passed into that check function, which returned to me true. Okay, so this returned true to me, and hence the length would be I plus 1. Minimum length of the prefix array would be I plus 1. So I return I plus 1. Otherwise I just check for the next. If this returns false, then I just increment my I from -1 to 0, 0 to 1. Okay, so this was a good O of n for me. O of n. Now we need to implement the check function. Okay, so check, first of all it is bool check, because we are checking. Bool check, we have int nums and we have int I. I is the prefix boundary. Let's just name it as prefix boundary. I is my prefix boundary. And so here what do we do? Now again, it is a simple loop. We initialize a variable called last, or let's just say previous for better nomenclature. We have initialize an integer previous. We initialize it as -infinity, basically integer dot min value, whatever it is in your language. I use Java, so it is integer dot min value, basically -infinity, and not infinity, the minimum value of integer. And now again we run our for loop. For int I is equal to I plus 1. Why I plus 1? Think. Why I plus 1? Length spelling is wrong. It is okay, does not matter. Why I plus 1? Why? Because my I indicates the boundary, the place where my prefix is ending. If my I is here, my prefix is ending here. So I need to start from I plus 1. Right? I need to start. So if this, my I was here, so this is my prefix boundary. And I need to start from I plus 1 till n minus 1th index. Right? That is what I need to check this. So this is I plus 1th index, and this is n minus 1th index. Okay, so I had named it. Okay, I is equal to, I'll just say this is p. I is equal to p plus 1, I plus plus, and if nums at I is greater than prev, continue, else break. Not break, just return false. And if this is complete, return true. So this would be my function. Now what is this function essentially doing? Let's see it with an example. 1 3 4 -1. Okay, so let's say my I was here. This is my boundary. This is my 0th index, first index, second index, third index. Okay, so I was here, so I am checking. What I am checking is essentially this part. I am checking this part. Okay, so my prev was -infinity. Then I started with my I plus 1th index. So is 1 greater than -infinity? Yes. So my loop continues. Is then, okay, sorry, very big blunder. I need to update my prev. This cost me a wrong answer in the contest. So I mean, while testing the test case, I did not submit it. So this is happening, and 1 is greater than 1, then 3 is greater than 1 because my prev was updated to 1. Okay, then it goes to 4 is greater than 3 because at 1 prev was updated to 3, and since I have reached the last index, it just returns true. If let's say this was 2, then this condition would have nullified and it would have returned false, and since it returned true, I can surely say that at the integer boundary I, at the prefix boundary I, the remaining is strictly increasing. So my minimum length is I plus 1. So I returned, right? So I think you all have understood this, and let me just tell you, this is the brute force approach. This costed me a TLE. Time limit exceeded. It is one of the worst thing that could ever happen, but it is okay. We try to optimize it. So what was our example? My example was 1 minus 1 2 3 3 4 5. Okay, this was my example. So how do we optimize it? This is giving me TLE, right? What we are doing is we are inside of a for loop. Why was this giving a TLE? Because this was O of n square, by the way. If you all did not understand, this gives me an O of n. Selecting the boundary gives me an O of n. And checking the rest of the array gives me an O of n inside of this. So hence it becomes O of n squared, and hence it gives me a TLE. So how do we remove that TLE? Now if you notice, what we are doing here, is that we are iterating through this array once. Right? Okay, we are doing that. So let's say we start checking while we are iterating, right? We define a similar length array, a boolean array, let's say a boolean array. We define a similar length boolean array, and we start checking while we are traversing for the first time, defining my boundaries. Okay, so so I start with 1. Is 1 in itself strictly increasing? Is 1. So right now, just assume that my prefix is null, empty. So is 1 in itself a strictly increasing number? Yes, it is. So I put true in here. Then I update my last to 1. So is minus 1 greater than last? No. So it breaks my it breaks the value, it breaks the prefix, it breaks the strictly increasing property, right? It breaks the strictly increasing property, yes. So I put false in here. Then my last is updated to -1. Now is my 2, now we come to 2, I is here. Is my 2 greater than -1? Yes. So I put true in here, because then this starts my new na. So is 3 greater than, so here it will become 2. Is 3 greater than 2? Yes, it is true. So here comes 3. Is 3 greater than, is 3 greater than 3? No, it is not. So I put false in here. Is 4 greater than 3? Yes. Is 5 greater than 4? Yes. So now what did we achieve from doing this true false true false? What did we achieve? Why did we do this? Why did we do this? Why did we do this? What did I think? Why did I think of doing it? So we are doing this, right? We are checking it any which ways. We are going through the entire array any which ways, defining our prefix boundary here, right? Might as well start checking right away, right? So if at any place false is coming, we can assume that this is my prefix, right? Because since it broke its strictly increasing property, this can be my prefix, right? Wherever it is breaking its strictly increasing property, we cannot consider it in the rest of the array, right? So might as well consider the prefix to be till here. So now what do we need? What do we need exactly? We need the minimum index. We need the minimum length. Such that we need the minimum length such that the remaining array, the remaining array is strictly increasing, strictly increasing, right? We need this, okay? So if you think about it very carefully, the last false index, okay, let me just show it to y'all. This is my index 0 1 2 3 4 5 6. So the last false index is the one where the remaining is strictly increasing part. The remaining is strictly increasing, right? So my last false index is where, so I have multiple false indexes, right? So the last false index is where my strictly increasing part starts, right? Because after that there is no false, there is nowhere, there is not a single element which is breaking the strictly increasing property, right? So my last false index is where the true strictly increasing starts. That means the part behind the false index, the last false index, is my prefix, right? So we need this length. So the length of this is nothing but the index of the false, last false, and that is my answer. So let's just quickly code it up. This would be an O of n time complexity and O of n space complexity. We can improve it to O of 1 space complexity as well. I will explain it to you while we are coding it up. So I hope you all have understood the problem. The problem was a simple one. It just required a little bit of thinking. So let's just quickly code it up. So int n is equal to nums.length. Then int last is equal to integer dot min value. Then int ans equal to 0. Stay with me. I'll explain what this answer is. This answer is nothing but it tracks the last false index. So why do we need, what essentially we require is the last false index, right? Then why need this entire array? Why need this entire array while we can just keep a track of the false index, right? So that is how we optimize it to O of 1 space. So yeah, so now int I equal to 0, I is less than n, I plus plus, I plus plus, yes. So now we check if nums at I is greater than last. If nums at I is greater than last, last is equal to nums at I, and then continue, else ans is equal to I, because here is the false, right? Since this condition breaks, this is my false index, strictly greater property is breaking here. So I change my ans to I, that means I am saving my false index, saving the last false index I encounter, right? And again I need this last is equal to nums at I. This also I made a big blunder. I forgot to update my last index here, and it became wrong. So I return my ans because this is the last index, and I quickly hit submit, and there you go, this answer is accepted, and I hope you all have understood this problem.